Okay, so we'll start. So last class we covered telnet and also we covered SSH, right? And also we started with what is dynamic routing. Okay, what is dynamic routing? We understood what is dynamic routing. We didn't do any configurations in the last class. Today we'll be doing it. So we understood what is dynamic routing, right? So basically, when you have two routers, right, instead of we go and configuring static routing on the routers, right, we can just go and make routers talk to each other. So basically, they do what they do, advertisements, right? So the routers will advertise about the network they have, advertise the networks they have. So this guy will advertise about whatever network that he has got. For example, if he has got 1.0, he'll advertise about that network. And this guy, he will advertise about 2.0 if he has got 2.0 with him. See, we covered this in the last class itself. Okay, so I'm not gonna again discuss the same thing. Let's go and understand what is OSPF, or maybe how to configure OSPF and get the dynamic routing done. The OSPF is one of the very important protocol ways, right? Usually in my CCNA class, I told no, I'll be discussing somewhere around 10 hours, close to 10 hours for OSPF. Maybe more than that also, I'm not sure. Even covering 10 hours of OSPF, still, the actual OSPF, the total OSPF concepts is covered only 25%. Okay, what I'm trying to say is, even if I discuss about OSPF for 10 hours, you will not understand OSPF completely, right? So you'll be hardly understanding only 25% of the OSPF, which means OSPF is a huge topic, right? And in this course, we're going to just discuss 30 minutes about OSPF, how the configuration is done, those things and all. So we're going to have OSPF's understanding very, very basic, right? Not even to the medium level. Okay, so let me log in into the lab. Okay, so here, wait, let me take you to the closest lab. Okay. So here you have free labs, right? So in this, we don't have OSPF. So last lab is SSH telnet, which I explained in the last list. I'll go and take the CCNA. I'll take the lab from there. So dynamic routing OSPF. So in this, we're going to discuss about this file alone, right? Let me just go and make a clone of it and then move it to the free labs folder. Okay. So good. Let's go and check it in the free labs right now. Free labs CCNA bootcamp. And here you have the OSPF. Let me rename this. Okay. So we'll take OSPF, 2 routers. Okay, so here you can see just we have a couple of routers here, and we have totally 3 networks in this lab. Let me start all the devices. Okay, so here we have, okay, maybe OSPF stands for Open Short Path First. That's the full form of OSPF. Open Short Path First. Okay. FIRST first. Okay, this is the full form of OSPF. It's nothing but dynamic routing protocol. So here you can see, when you see router 1 has got 2 networks with him, which is 1.0 he has got with him, and also that network is connected with him. And also he has got 3.0 network connected with him. Okay. And same way, if you see router 2 has got 3.0 network connected with him, and then 2.0 network connected with him. Okay, so these are the 2 networks that is connected to router 2. So now what happens is, what I'm going to do is, I'm going to simply, I'm going to enable OSPF. So I'm going to enable OSPF on the routers, right? So once that's the command that I have to configure. We don't have to do any static routing. I'm just going to enable OSPF on the router. In fact, now instead of saying it as a enabling OSPF on the router, the right term is to enable OSPF on the network interface card, right? What is network interface card? The NICs, right? So the interface. So this is what NIC, this is what NIC. So you can call them as NIC, or you can even call them as interface. Okay. So what I'm going to do is I'm just going to enable OSPF on the network interface card. So I'll just tell you how to do that. And as soon as the OSPF is enabled on the interfaces, right? First, I'll tell you how to enable OSPF. So let me go to the router 1. So yes, let me set the host name to host name R1. Okay. So now the command is very simple, guys. Router OSPF, and then there is a number that you have to give, which is basically called as a process ID. See, there is no need to discuss much about this number because in CCNA it is not that much very important. So I'm not going to discuss more about it. I'll just give some numbers randomly. Right? You can use whatever number you want. Right? If you want one, you can use one here. If you want to use 100, you can use here. No issues. Whatever number you want, you can use. I'm just going to use one OSPF one, process ID one. And once you give router OSPF one, then what happens is we are into the protocol, right? We are into the dynamic routing configuration. So here, if I give question mark, you can see so many commands over there. So there are so many things that you can do in OSPF. Right? Can you see? Like, so close to 50 plus commands that we have in OSPF alone. Okay, so the one only command that I'm going to use is I'm going to use a network command, right? So network and then 192.168. I'm going to say 1.0, 0.0.0.2 seconds. See, it requires more time to perfectly explain what is this, but with the restricted time, I'll just explain what is this very briefly. So the command I'm giving in the router is basically network. Okay, and then I'm typing the network address. Right? What is this network address? 1.0, right? So I'm typing that 192.168.1.0. And then this is the wildcard mask, which is 0.0.0.2 seconds. Okay, this is the wildcard mask. So we call this is what we call this is wildcard. Wildcard. So the meaning of this is, right, in the wildcard, wherever you have 0, right, that is something that you have to focus. Okay, so you just wanted to focus on that. And wherever you have 255, basically we're gonna call it as don't care. We're not gonna care about it, don't care. So basically the wildcard bit has got two portions, focus portion and then the don't care portion. Focus is wherever you have 0, that is what you have to focus. Wherever you have 255, that is something that we don't have to focus. So which means what I'm trying to say is when I give this wildcard mask, which is 3 zeros, I'm asking my router to concentrate on the first 3 octets in the IP portion, right? This is the IP portion, right? This is the IP portion. This is the wildcard mask portion. So in the wildcard mask, how many ever zeros I give, that number of octets alone, the router have to concentrate on. So when I give this command, when I 192.168 1.0 0.0.0.255, I simply say the router, hey router, please concentrate on the first 3 octets. Because why? Because we gave only three zeros in the wildcard mask. So now what happens here is once the router gets this command, it's gonna start searching for the interface which starts with 192.168.1. Understand? Let me clarify what I'm trying to say. So here network and then the command is 192.168.1.0 and then the wildcard mask is 0.0.0.255. So in which wherever you have 0, that is the focused portion, right? Which means we are just trying to focus on the first 3 octets, 192.168.1. Okay, so now when I give this command, router understands like this, right? Which means I'm saying the router enable, right? Simply like this. I'm saying the router enable OSPF on the NICs, on the NICs, on NIC, on network interface cards or network interface card, which starts with, understand, this is very important because many people, even in the YouTube or I've seen many, people explaining OSPF, they don't give the proper understanding about wildcard mask. Here, I don't have enough time to explain wildcard mask because we have to complete ACL and tomorrow's the last session. I need to complete few more topics also. That is why I'm kind of rushing up here. Yeah. So anyway, I'm not gonna I'm not gonna rush it so much, right? I just wanted to give a brief understanding about OSPF. So let's try to understand this. So what I'm gonna do is enable OSPF on NIC, which starts with, that is an NIC, which starts with, what is the focus for here? What is the focus? We gave only 3 zeros, right? Which means it says 192.168.1. Okay, I gave the command here. See, I gave the command here. The command starts with 192. This is the IP portion, and this is the wildcard mask portion. In wildcard mask, I say 3 zeros, and which means I say the router just enable OSPF on the interface that starts with 192.168.1. So that starts with 192.168.1. That's it, right? Because why? Because I focused only on 3 zeros, right? First 3 octets I focused. Okay, so enable OSPF on the interface that starts with 192.168.1. So now you guys can see which interface has got an IP address that is starting with 192.168.1. This guy is 192.168.1.1. This guy is 192.168.3.1. Which interface starts with 192.168.1? Of course, this interface, right? So what happens is now the router will enable OSPF on this interface. It's going to enable OSPF on this interface. As soon as it enables OSPF on that interface, what happens is it's going to send the hello packet. So it's basically called as OSPF hello. Now I'm going to give enter, right? Or maybe I'll show you. We'll just make a Wireshark capture here. Capture, sorry. Wait. Yeah, so capture 0/0 interface. I'm just capturing over there. So whether I just want you guys to see how the hello packet exactly looks like. Okay, so yes, the capture is not initialized yet. Okay, done now. So I'm searching for OSPF and I have the command here. And also one more thing, guys, OSPF comes with some area concept, which I'm not going to explain here. So here you can see in the diagram that both routers are going to be configured one area called area 0. So definitely whenever you configure OSPF, area is also important. I just understand area is something that is important. We are not going to discuss more about area in this section. Okay, so I'm just going to give enter. And what happens? So now it's going to enable OSPF on the interface that starts with 192.168.1. It's going to enable OSPF on this interface. Okay, and as soon as it enables OSPF on this interface, it's going to say hello. Okay, now we can see the hello packet. Can you see what is going on? Right, OSPF hello packet. So it's going to go to a particular interface that's going to say hello. Right, and what is the frequency of this hello is for every 10 seconds. For every 10 seconds, this guy will go and say hello. Right, and the hello going to go to both the PCs. And what the PCs will do? The PCs are simply they're going to drop. Because why? Because OSPF, the PCs are not able to understand. Right? OSPF is a routing protocol which the router can understand. This guy can understand OSPF. This guy can understand OSPF hello packet, but PCs cannot understand. So when the hello packet comes to the PC will simply drop it, right? This PC will drop, this PC will drop. So what happens right now is we configure some commands in the router. Okay, so that command enables OSPF on this interface, and then it sends hello packet for every 10 seconds, and the hello packet goes to both the PCs, and both the PCs will drop it. Okay, and also I just want you guys to see one more thing here. Can you see the destination IP, guys? Destination IP. Source IP is 1.1 because right? Because this is IP address, right? The packet is coming from this IP. But what is the destination IP? 224.0.0.5. What is it? Right, that is multicasting. Okay, we discussed now when I was talking about IP classification. This is class D, right? Class D starts with 224. So it's a multicast IP address. Right? Again, I'm not going to discuss much about multicasting here. Okay, it's a multicast IP address. So it's actually a nice way to communicate between a group of devices. Okay, so now again, what I'm going to do is I'm just going to go here. Again, I'm just going to give up arrow, right? And I'm going to type one more command, which is going to be 3.0. So when I say 192.168.3.0, right? This is the network portion, this is the IP portion, and this is the wildcard portion. So in wildcard, how many zeros I've got? 3 zeros, which means what is the focus here? The focus, the number of octets we have to focus is 192.168.3. Now, the same way, when I give this command, right? Let me just go and capture this interface also. Okay, capture 0/1 interface. That's the other interface. Okay, so please give me a few seconds. This initializing, yeah, done. So OSPF again. Now I'm going to type this command and I'm going to give enter. So what happens right now is now OSPF is enabled on this interface because this is the interface that starts with 192.168.3, right? Because the command I gave, the second command that I gave was 192.168.3.0, 0.0.0.2. Now here the focus is 192.168.3. Okay, this is the focused portion. Right now it's going to enable OSPF on the interface that has so it starts with 192.168.3. So which is the interface? This interface. Now here this guy will say hello. Okay, and here also this guy will keep saying hello for every 10 seconds. Right now OSPF protocol is sending hello on both directions. It is sending hello on this direction. It is sending hello on this direction also. Okay, good. Right now, since we have not configured the second router, right, we're not gonna have an OSPF update because here if you see, can you see this side? This is the other interface, right? The packet OSPF hello packets is coming from the source IP address of 3.1. Okay. So now what we'll do is we'll just go and configure the second router also. The same way, I'm not going to explain things separately on the second router. We're going to enable OSPF on both interfaces. So I'm just going to choose this interface and choose this interface. So we're going to enable OSPF on both interfaces. Okay, so EN quantity router. So first we'll set the host name. Host name R2. Next is router OSPF1 command network 192.168. 2.0, maybe I'll enable on interfaces. So first I'll start with 2.0. I'm going to enable OSPF over here. So what happens? This side the hello packet will be sent. And again, I'll be enabling this interface. So this side the hello packet will be sent. So the hello packet is going to be sent on both directions, the second router also. Okay, so yes, we'll just go ahead 2.0, 0.0.0.2 area 0. Okay, have them in same area or else it will not work. Network 192.168, 3.0, 0.0.0.255 area 0. So understand the moment when I give 3.0, what happens is here the hello packet. Here the hello packet goes, I think goes to the PCs. What the PCs will do? They drop it. But this side, this guy is sending a hello packet, right? Now OSPF hello packets goes on both sides. Right? It goes on this interface, it goes on this interface also. Now, when the hello that is sent by the first router goes to the second router, the hello sent by the second router goes to the first router, and that is where they discover each other. Okay, when I say hello, or when router 1 says hello, router 2 is discovering him. When router 2 says hello, router 1 is discovering. Right? After they discover each other, they become neighbors. Okay, they become neighbors. After they become neighbors, they're gonna exchange, or maybe I can say they'll start advertising it. Okay? They'll start the advertisement. Yeah. When understand that here. So the this is the capture. Only one side the hello packet is giving. The moment I configure here, I configure. Now you can see first hello packet. Can you see guys here? Okay. So let me. Yeah. No. The every updates are happening here. Now you can see there is a hello packet came from 3 point, which is from the second router. And after that, they discovered each other. And after that, can you see all these black color packets? These packets are basically the advertisement packets. They exchange everything. And finally, I'll stop the. Now, what happens is, meanwhile, between the routers, what happens is you're gonna have the advertisement happening from R1 to R2 and R2 to R1. So what R2 will say? R2 will say that he has got 2.0 network, which he'll advertise to R1. So once router 2 advertises about 3.0 network, 2.0 network to R1, R1 will know that, okay, there is a network called 2.0. And what is the next hop IP address where the advertisement came from? The advertisement came from 3.2 IP, right? So the next hop IP address is going to be 3.2. So which we're going to see in route 1 routing table. So usually we see yes, no for static. Since it is OSPF routing, we're going to see O. Okay, I'll just show you on the first router. We're going to see now. Can you see there is a update here? There is a neighbor update. Okay, so they found their adjacent neighbor, adjacent device. So now we'll check the routing table. Do show IP route. You'll see the routing table. Do show IP route. Here you can see there is an OSPF entry. Okay, it says what? It says that 192.168.2.0/24 can be reached via 3.0. So this is what we'll be adding in the static routing, right? In static routing, we'll try to add this only. Right now, the same thing it is getting added with OSPF. Right, the routers talk to each other and they get the advertisement. Now, please guess what first router will advertise to the second router. Right, during this exchange was happening now. What first router would have advertised to the second router about which network? About 1.0. So first router would have advertised about 1.0 to the second router, and second router knows about 1.0 now. Earlier he was not knowing 1.0. Okay, now he knows about 1.0. 1.0/24 network can be reached via what is next to hop IP is 3.1 because it came from this is 3.1. Can you see here it's 3.1? Okay, so now we'll go to the second router and check it. So do show IP route, we'll see the routing table. And now can you see there is an OSPF update about 1.0/24 and that can be reached via 3.1, right? Now all we need to do is guys, right, when you have many routers, let's say even if you have hundreds of routers, all we need to do is in all 100 routers, we have to enable OSPF. That is only the thing that we have to do. So if you enable OSPF on the interfaces of all the 100 routers, what happens is they'll send hello packet to all the other devices, right? And they'll discover all the nearby devices. And once they discover all the nearby devices, they'll start sending the, right? They'll become neighbors and they'll start exchanging the networks. So once they exchange networks, You don't have to go and configure static routing in a big network, right? Automatically, these routers, they'll talk to each other, and every router will advertise the network that he knows. So finally, what happens is, if you have hundreds of routers, every router will know all networks that is there in the network, right? We don't have to go and configure static routing. So last class I told you. So what is the difficulty in static routing? Right? In large networks, static routing is tough, right? So for large networks, we're gonna go with what technology? We're gonna go with something called dynamic routing. So in dynamic routing, OSPF is very, very important. In the interviews also, OSPF is very important. Or maybe EHR is also popular, and BGP is very, very important, right? So these are the three protocols. The idea is same, but it is done, it is implemented in a different way, right? The way of working is different, but the motive is exactly same, right? Likewise, we have many other protocols also. I told you in yesterday's class, RIP, it is almost obsolete. No one is using RIP nowadays. But OSPF is still used, EHR is still used, BGP is also. No, that is used, and that's going to be, these protocols are going to be used forever because they are very important routing protocols that we have got. Okay, so with this, I'll finish dynamic routing. I know it's a very short session, right? What is the basic idea? Routers, they basically do advertisement to each other and get the routing table updated, right? That's what the point is. Okay, so yes, now we'll just go and Uh, Bonesh, it works on three routers also, right? Maybe if you want, you can run OSPF on three routers topology, which we have in our NG lab itself. It works the same, right? No, three routers, those routers who are connected will become neighbors. Okay. Okay. So just give me a minute. Okay, just give me a minute, guys. I'll be back. Okay. So now, what we'll do is, we'll close this and we can understand the next important topic, which is ACL. Right? I'm trying to complete ACL in today's class because tomorrow we have to discuss about network address translation, which is also important, and also we have to discuss about what is firewall, and also I want to discuss about what is VPN. So these are the topics for tomorrow's class, and tomorrow is the farewell for this course. Okay, so tomorrow we're going to complete this. This is the 15th session. So today I just want to complete ACL. So if I complete ACL today, then I can have these three topics basically covered in the next class. Okay. So yes, so we'll get into ACL. Yeah, what I'm going to do is right now I'll go to my CCNA folder, go to ACL, and just copy the lab. ACL. Okay. So let me add these labs. Okay, clone this guy, remove it to three labs, and also we'll just take one from external ACL. And yes, I'll clone this lab and clone this lab. We'll copy these two labs. Okay, so yes, going back to my our CCNA bootcamp folder. There here we'll just go and rename it. Name number external ACL. So this will be 10. Mm, sorry. Okay. Uh, yes. So please wait. So here the order is not clear. Okay. So anyway, I'll rearrange it later. You could see some labs here. Uh, yeah. So first I'm gonna go and take. See, it's not in order, right? Till OSPF we have it correct, and then standard ACL. No, I couldn't find the order over here. Just give me a minute. I'll try to do this. Nine hyphen one we'll have it, because when you give 10, it's taking in the first place. Okay, here this time we'll make it there. 9, 2. Okay, I think now it's kind of clear. So we completed till lab number 9. Now we are just clicking on 9.1, which is a standard ACL. Okay, let me open this. See, this is actually a very interesting topic. ACL access control is very important, very interesting and important too. Okay, because every organization they'll expect you to have as a network engineer or maybe a firewall engineer or a person who's looking for opportunity in networking. Uh, ACL is very important, right? So this is going to be important because ACL, what ACL is about, it's about full of restricting factor restrictions. Okay. See, so far we have discussed many topics. Uh, the goal of that topic was to establish the communication, right? We want the thing to work. We want the communication to work. But ACL is just a reverse of it. Like here, we're gonna block some traffic and check whether they are getting blocked or not. Because organization, everyone does it. Maybe you can be a college guy, or a working professional, doesn't matter, right? If you are, you might have noticed that when you go to some unwanted websites from your organization, maybe some some unwanted websites, let's say, I don't want to mention any website name. Let's say that you just went to this particular website which is unwanted according to the organization, right? You might have seen some kind of a blocked page, correct? Okay, you'll see no, the website doesn't work, or maybe the site has been blocked in your organization, or you get an error saying that this site has been blocked, so and so, right? How that blocking is done, right? That blocking is done, how it is done, the basics of that is what you're going to understand in ACL. Okay, so ACL has got two types. So one is standard ACL, and then the other one is extended. Okay, so standard ACL and then extended ACL. This is going to be really interesting, guys. And we'll understand the theory first, and then we'll do the lab also. Okay, standard ACL, extended ACL. Standard is basic, right? Maybe if you want to do some basic restrictions, some basic blockings, then you can go with standard ACL. Maybe all the advanced stuff, right? Advanced ACLs, advanced, advanced ACL. Advanced stuff can be done with the external ACL. So we're gonna have one lab with standard ACL here, and then we're gonna have two labs with external ACL here. Okay, so let me just start with standard ACL, walk you through the lab. You can understand how it basically works. Again, see, ACL is not a topic to understand. It's not a concept. Okay, the concept is very simple. What is the concept? The concept is block something. Okay? So you can understand ACL very well by solving multiple tasks. Okay? That is why in my actual CCNA class, I used to have 6 tasks per standard. Here we're gonna understand that with one task. Okay, so the more and more tasks you find in ACL, that is where you understand things very clearly. Okay, so here, just for the basics understanding, we're gonna take this task one, and the task one says that we'll be taking care of this. Okay, so here task one says what? Task one says that ping from 1.2. Okay, so ping from 1.2 to 2.2 and 2.3. Okay, should be blocked. Can you understand that the content is what? The content should be blocked. So you cannot take 1.2. I mean, if you ping from 1.2 to 2.2 or 2.3, it should be blocked. Whereas 1.2 should be able to reach all the other hosts. Okay, it should be able to reach all the other hosts, but not this text. So here, this communication alone should be blocked. Everything else can work, which means whatever I'm putting in green can work. So this can ping this guy, he can ping this guy, this guy can ping this guy, this guy can ping this guy. No, all these communications can work. Which alone should not work? The one that I highlighted in red color, right? That communication alone should not work. Okay, so we can do that with the help of routers, right? So we can go to the router and then we can configure ACL over there. Okay, yeah, let me get into the router. I'm just going to choose router one here. Let me start all the devices. Let me click on router one. It's actually booting. Okay, please wait. Yeah. So I'm in router one right now. So how do I configure ACL? I need to go to the configuration mode, and then I can give access list with under the command, and I can give question mark. Now it says that if you want to create a standard ACL, which we're gonna do right now, please choose any number between 1 and 99. And if you want to use external ACL, you can choose any number between 100 to 199. So I'm going to do standard only right now. So I'm just going to use standard. I mean, I'm going to use number 1. I can use any number that I want, but since the first number itself is available, since it's not used, I'm starting with the number one. So access list one, and the next question mark if I give, right? I'm just trying to give question mark to find out what are the upcoming commands. Okay, when I give question mark, it says directly it's asking what do you want to do. You want to deny or permit or remark. See, remark is not that important because it's just a comment. You can say no, it's just a description. Right? So no one will, or maybe I will not use remark. Either I'll be using deny or permit under. Okay, so if you use deny, it's going to specify the package to reject. Okay, if you give permit, it's going to specify package to forward. Okay, so what I'm going to do right now is I'm going to go and then give deny. I'm going to say deny. Okay, now if I say deny, now it's asking what to deny, which device you want to deny. See, you can understand like this case. You can block a device, maybe no, the restriction can be done in three levels. One is you can block one single device, right? You can block one single PC. Single PC can be blocked, right? Or else you can block everyone. These are the different scenarios, right? Maybe you can block a single device, or you can block everyone, or you can block a network. So these are the three requirements that we three kind of scenarios that we may have network. Okay, so now how do I block a single PC? So single PC can be blocked with a command host. So if you use a command called host, and then you have to give the IP address of the PC, IP of the PC that you want to block. So for example, if you want to block 1.2, I can say host, and then I can say 192.168.1.2. So this PC will be blocked, or any packet that is coming from that PC will be blocked. Okay, now here, if you want to block everyone, right? In that case, you can give any. So any is a syntax, right? You can just use any and you can block everyone. Or if you want to block a group of devices or maybe a network, what you can do is you can use the network address, right? So you can use the network address of that network, right? And then you can use the wildcard mask, right? The same wildcard mask that we discussed in OSPF right now, wildcard mask. Okay, so in that case, if I wanted to block 1.0, assume that I want to block network 1.0/24, the command will be like this. The command is going to be directly you can go and type the network address 1.0, and then what is the wildcard mask? 0.0.0.255, which means I'm going to block all the IP addresses that starts with 192.168.1, which means the whole network. I mean that the whole network can be blocked with 192.1. The whole network can be blocked with this network address and then the wildcard bit. Again, the same concept. 3 zeros means just focusing on the first three of it, 192.168.1. Okay, so now here what we have to do, what what is our scenario? Our scenario, right? We are trying to block a single, right? So what we are saying is, we are saying that 1.2 should be blocked while reaching 2.2 and then 2.2. Okay, everything else should be allowed, which means we are targeting on who? We are targeting on a single PC, right? A single PC is what we are trying to block. So in that case, what happens is you can go and say host, right? Single PC, what did I say? For single PC, the command is host. So I'll just go and type host again. Okay, and I'm going to give question mark. Now it's asking me give the IP address, right? Just give me the IP of that device. So what I'm going to say, 192.1.2. Okay, very good. So I'll just give 1.2. So now I created an ACL that is denying which device? That is denying device. Okay, we'll just give do show IP route. Oh, sorry, do show IP, do show access. Okay, yes. Okay, guys, am I clear to everyone? Is my voice breaking, guys? Please acknowledge. Yeah, so I'm clear now. So I think Venkatesh, if my voice is breaking for you, then it might be your interpretation. Please check from your side. Okay, so yeah, coming back to ACL configuration, do show access. So here we are trying to configure an ACL. This is the command actually. So access 1 deny host 192.168 1.2. So now when I try to print the ACL, right, I'm seeing what ACL it is. It says there is a standard ACL with a number 1 and R list, right? ACL means access list, right? And that ACL or that access list says, wait, access says that we are trying to deny 192.168 1.2. So this 10 is basically a sequence number. I'm not going to discuss this here. So we'll just understand that there is a deny statement which is denying 1.2. Okay. Yeah. So again, I'll show you the command using here. Show access list. Okay. So access list. and you can see that there is one list with number 1, and there is only one line in that list which is deny 1.2. Okay. Now, what you have to understand is, see, once you create an ACL, now I have created an ACL. So the ACL number is 1, the ACL number is 1, and how many lines we have in the ACL? We have only one line in the ACL. What is that line? Deny 1.2 or deny host 1.2. Now, this ACL number 1, which has got only one line, right? Now, if the ACL is just like that there, it's not going to be useful. You have to apply the ACL on the interface. Right? So ACL, if you just create the ACL, it's no use case. So right now I've created the ACL. There is no use of it. The ACL is there in the router, but it is not going to be in effect. So if you want the ACL to be in effect, then what it does, you have to apply the ACL to the interface. So because you have to give it to the interface to block it. Now I want you guys to guess which is the right interface to apply. So I'm going to give this ACL. I'm going to say deny 1.0. The ACL is ready. But are we going to give the ACL to this interface, option B, sorry, option A, or option B, or option C? So which interface do you think is correct? Okay. See, you can answer me personally also. Yeah, so now definitely option C is not in the race. Because why? Because the packet flow is going to come from here, touch this A interface, and then cross this B interface, right? So maybe either you can decide to apply the ACL on this interface, or you can decide to apply the ACL on this interface. But I'll tell you which is the right interface. Yeah, so anyway, option B is not in the competition. Okay, we'll try to understand why, which interface is right and why. See, option B is correct actually. Why option B is correct is because when you apply it on option A, let's say when you're applying it on option A, what happens is when you try to send, assume that you are trying to send a packet from 1.2 to, assume that you are trying to ping here 4.2. So when you're trying to ping from 1.2 to 4.2, even in that case also, what happens if you give the list to this interface, the interface will see the packet. And if the packet is coming from one point itself, then what it will do? It will block the packet. So which means when you apply it on this interface, you're blocking too much. So 1.2 can't even reach 4.2. 1.2 can't even reach 5.2. So you can understand why it is why we should not apply it on the first option, which is 0/ interface. You should not apply it here because you're over blocking it. Okay. So whereas if you apply it on this interface, let's say, so instead of this interface, you're applying the ACL on this interface. Okay, when you apply it on 0/1, now what happens is assume that you apply this ACL on this interface. Okay, now assume that you are trying to ping from 1.2 to 4.2. Will it flow now? Yes, of course it's going to flow because why? It's going to go here and it's going to go here. So we are, can you see it is touching this interface and it's touching this interface. There is no ACL in these two interfaces. The packet will just like that flow and ping 4.2. Whereas if you try to ping 2.2, assume that you are trying to ping 2.2 from 1.2 to 2.2. In this case, what happens? You send, and this interface will make a routing, and your packet is gonna leave this interface, right? So when the packet leaves this interface, it is touching there. Means it is touching that interface. That time, what will happen? If the packet is coming from 1.2, if the source IP, right? If the source IP address is 1.2, that is what we told in the packet. If the packet is coming from the source IP of 1.2, we want it to get blocked. Okay. So now the packet will get blocked, and it's gonna get blocked by this interface, or this interface is gonna block the packet. So perfect. So which interface is right? Of course, 0/1 is right because if you apply it on any other interface, you are just trying to do overblocking, right? If you apply it over here, then you're overblocking it. So if you apply it over here, then it is perfectly blocking. Okay, so I'm just gonna go to that interface. Conp interface G 0/1, right? That is the interface G 0/1. This interface, I'm gonna apply the ACL over there. Access list, sorry, the command is IP access to. That's the command. And I'm going to say, what is the number? What is the ACL number we created? The ACL number was 1. No, I need to use that number over here. And I'm going to say question mark. Right now, this is the next confusing part. So which direction it is going to be? Right. Okay. So now direction is important because when I give the ACL to this interface, I need to say the direction also. Now, I want you guys to guess which is, there are two directions. One is inbound, the other one is outbound. You can see two directions, the inbound, outbound. I'll give a couple of colors, guys. So one is blue, the other one is, let's say green. Okay. Now say, which is inbound and which is outbound? Which color? Maybe this is, let's say A, and let's say B, right? Which is inbound, which is outbound according to you guys? Now please try to answer the chat. Yeah. So I can see people are answering. Okay. So here, if most of the guys, even in my classroom training also, most of the guys say that this is inbound. Okay. And they'll think this is outbound. Okay. That is actually wrong. It is actually wrong because if you see this is inbound, then wrong. Why? Because you have to see from the interface point of view. Just see from this interface, which is inbound, which is outbound. For this interface, which is inbound, guys. For this interface, this is inbound, correct? So most of you answered, but the answer is wrong. This is inbound. Something that is going towards the interface is inbound. That's something that is going out of the interface, right? That is leaving the interface is outbound. So this is correct. So blue is out, green is in. Okay, got the point? So you have to see from the interface point of view. Can you understand? You have to see it from the interface point of view. Okay, so something that leaves the router is outbound, something that enters the router or something that enters the interface is inbound. So this is outbound. Now, which direction we have to apply the traffic on? Right? Of course, if the traffic starts from here, it's just gonna go to this interface and can you see it's trying to leave the interface, correct? It's gonna go out of this direction. So I go to the router and say that if any traffic is going out of this interface, if any traffic is going out of this interface, check the ACL, and if the packet is coming from 1.2, deny it. Got the point? Yeah. So now what I'm going to do is I'm just going to give outbound. Got it? So outbound. So what I'm technically saying to the router is, if anyone is crossing this interface, right? Assume that the packet is leaving this PC, coming here and trying to go out. So when the packet is trying to leave out of the interface, right, that is where the interface will not just like that send it outside. The interface will, if the packet wanted to leave this interface, if it want to go to outbound direction, now the router is going to stop the packet and ask whether it is coming from 1.2. And if the packet comes from 1.2, you're going to perform the action called deny. Okay. So yes, so applied this on the outbound direction. Can you understand why it is faced outbound? Because traffic is going outside. So we are filtering the traffic that is going to go out of the interface. And if it is 1.2, we want that to get denied. Okay. Yes, so let's go and ping right now. So earlier ping used to work, but this time when I try to ping 192.1.2.2, can you see it's not working? The ping is failing, right? Can you see the ping is not working? I'll just give Control C, and you can see 6 packets, right? So you can see the packet loss case. Packet loss is 100%. Okay, now I'll just go and show you this. Do show access list. Okay, can you see here? The matches here. The matches means so far 12 packets came from the 1.2. So there are 12 packets so far came from 1.2, which was matching this line, and the action was denied. Okay, so so this means the matches. Okay, again try to ping it, right? I'm just gonna ping again. Again, I'm gonna generate some traffic from 1.2. Again, this match is gonna keep increasing, right? Let me just go and refresh it. Just give up arrow. Okay, so line number 1, again it's getting denied with now it got denied with 26 matches, right? Now this count is going to keep increasing because parallelly behind the scenes the thing is going on. Can you see the matches increasing? Okay, because here the thing is going on. So now if you find the match over here, which means there are totally 56 packets so far came from the source IP address of 1.2 crossing that interface. That is what very important. So far 56 packets, right? 56 packets came from this PC trying to leave this interface and they got denied. Okay, the result says deny action is denied. Okay, so now we just wanted to try this, right? Maybe in ACL or when you try to learn ACL, you should never get settled with one scenario alone. So now we understood that this is getting blocked, but we should not settle with it. We have to try all the other possibilities. Now I want to take 1.2 and I'm going to ping 4.2. I'm just going to see whether it's going to work. So we'll take 1.2 PC. The same PC only. This time I'm going to ping 192.168 4.2. So 4.2. That is working. Why? Because on the way there is no ACL applied. Because when I try to ping 4.2, I will be touching this interface. Again, I'll be touching this interface. Again, I'll be touching all the interface. I'll be leaving. But ACL is applied on which interface? ACL is applied on this interface. So since I'm not touching this interface, 1.2 can talk to 4.2 or 1.2 can even talk to 5.22. Okay. So now this is something other side you have to also check, which means 1.2 is getting blocked when you ping 2.2. or even when you ping 2.3, it will get blocked. But it works when you try to ping 4.2, or it's gonna work when you try to ping 5.2 also. But now we have to check the other thing. So now let me take 1.3 and ping 2.2. Okay, I'm just gonna take 1.3 and ping 2.2. So we'll see whether it's working or not. 1.3 to 2.2 should work, right? Because according to our condition says only what? Our condition says only deny 1.2. So 1.3 should technically work. So I'm just going to go and ping 2.2. We'll see what the output is. It's not working. Even 1.3 is not able to reach 2.2. We blocked only this red color line, right? Why this is not working? And also, when I take this PC and I try to ping this guy, let me see whether that is working or not. It will make 4.2. Oh, this PC is not opening. Okay, let me wipe this guy. Why is it not opening? Or maybe I can take this PC if it works. Okay, I think 4.3 is opening. Let me ping from there. So I'm trying to ping 2.2. Then that is not working. So which means what I did is, right, I just broke something that, instead of blocking 1.2 to 2.2 and 2.3, I blocked everyone, right? See, this guy is supposed to work. This guy is supposed to work, right? But that's not working. This guy is supposed to work. That's not working. This guy is supposed to work. That's not working. Why no one is not able to reach 2.2 and 2.3? So now what I did is, instead of blocking 1.2 alone, I blocked everyone reaching 2.2 and 2.3. But if you see the ACL, check the ACL again. Do to access this command, Now I can see that there is only one line, right? And there is only that match, right? That match is what happened earlier. But now we don't see any packets, any new packets getting blocked here. So this line matches only 1.2, and there is no more line that we have in the ACL. Then why is this 1.3 also getting denied, and why is this 4.2 also getting denied? Why is every other PC is getting denied? Okay, so this is a very critical part of ACL. See, when it comes to network security, okay, so there are wonderful courses we have for network security, basically firewall, right? So if you're a person who's ambitious in learning firewall, please do it. That's very important, device in networking, network security. So in firewall, right, we have many ACL concepts over there. Even for firewall also, or even for proxy servers, right? This concept, right, the one that you guys are studying today, that is the basics for that. Okay, yeah. So every in firewalls we have ACLs, in proxy servers we have ACLs, but every ACL works the same way. Right now we are learning ACL on routers, but ACL concept is same. Okay, it works the same way on all the devices. Okay, I want you to understand the behavior of ACL first. Okay, so now I'll explain what happened and why it didn't work. So we have a router and we have a switch. Again, that is switch 1 that is connected to switch 2. Okay, and we have 1.2 PC here. We have 1.3 here. We have 2.2 here. We have 2.3 here. Okay, and we have 0/0 interface. We have 0/1 interface, and this guy is 1.1, and this guy is 2.1. Right? This is the exact scenario right now. And what did I do? In this router 1, I created an ACL. ACL list number is 1. And how many lines we have? Right now we have deny host 1.2. Okay, this is one and only line that I have right now in the router. Okay, and the ACL is applied on which interface? On this interface. Okay, now let's try to understand. See, for you guys, you can see only one line in front of you. So deny host 1.2. But how it basically works is, right now we have two lines in the ACL. Okay, in this ACL, the number one ACL, this number one ACL, we have two lines. So what is the second line? The second line is deny all. The second line is deny all. There are two lines, right? And when you see here, it won't show it up. Here, if you see, when you give the output of the list, it says there is one list, and what is the only line that we have? There is only one line that is deny 1.2. Understand, the line is deny all line, and that deny all basically it is called as implicit. Implicit means it is hidden. This deny all is hidden, and this deny all will not show up in the output. When you try to use the show command, it's not going to show up in the output because it is implicit, but it is there. Okay, now how many lines we have in the ACL? One line that we created, right, which we can see, and there is one more line which is deny all, which is hidden in the ACL. Okay, now let's try to understand the same scenario. Okay, so assume that I'm trying to ping from 1.2. From 1.2, I'm trying to ping 2.2. Okay, now what happens? From 1.2, I'm trying to ping. So the ping packet will be leaving this PC, okay, and going to this router and trying to leave this interface. Since the packet is trying to go out of the interface, what we told to the interface, if any packet leaving outside, apply what? Apply the ACL or check with the ACL. Try to ACL has got two lines. Okay. So now when it is leaving this interface, the router interface is not going to leave the packet. It's just going to stop it and ask some questions. What the question is. Now the packet is still in the interface. It is about to leave, but the router stopped it and asking this question. And the packet, the router is asking, or the interface of this router is asking, hey packet, are you coming from 1.2? That's the first question. Because what is the first question? The first question is denying 1 point, right? Now assume that the router is asking block 1 point, or are you coming from 1.2? And what the packet will say? The packet will say yes, right? Because why? Because if you see the source address of the packet is coming from 1.1. It is coming from 1.2. So now the first line matches. Right here, the line matches. The first line is matching because the packet is coming from 1.2, and in the first line we have 1.2 IP. So the packet is matching on the first line. Now, if the packet is matching on the first line, then what is the action for it? The action is denied. Okay, the action is denied. So what happens when you send this packet based on the first line's information? There is a match that is happening on the first line. Once the packet is matching, the action will be executed. What is the action? The action is denied. Okay, that is why any packet that is coming from 1.2 is getting denied. Makes sense. Okay, now let's try to send a packet from 1.3 and understand why that is also getting denied. Okay, now I'm sending a packet from 1.3. Okay, I'm using this PC to ping 2.2 to the destination of 2.2. Now this packet, which is come from the source address of 1.3, it is trying to leave this interface. Okay, now it is trying to leave the interface. Same question. The interface stops the packet, asking him, "Hey packet, are you coming from 1.2?" The packet will say, "No, no router, I'm not coming from 1.2. I'm coming from 1.3." So what happens? There is no match on the first line. Okay, since there is no match on the first line, what happens is that is the time where the router will check the second line. Now there is no match, right? Because the packet is coming from 1.3. Here the first line is having 1.2, so there is no match. Now the router will look into the second line and see is okay. If you're not coming from 1.2, are you coming from some IP address? Right? Now who will match on the second line, guys? Everyone. Everyone is going to match on the second line because why? Because second line says deny all. Okay. Yes. So now since everyone matching on the second line, now when you send the ping request from 1.3, everyone matches, right? Now this packet is getting matched on the second line, and now the action is what? The action is again denied. Okay, that is why even 1.3 is getting denied. Even when you try to ping from 4.2 also, why that is also getting denied? Because 4.2 is not matching on the first line, but it is matching on which line? It is matching on the second line. I understand this is the behavior of the ACL. Now I understand that why it is not working now, because there is a denial statement in the ACL. Okay. So now since there is a denial, that is why others are getting denied. Then what do I do? So can I remove this denial? Can I delete this denial from the ACL? Not possible. You cannot delete the denial line because that is implicit. You cannot remove it. That will be always there. But what I can do is the denial, one advantage is the denial will be always the last thing. Last thing. So which means what I mean the last thing is if you have one line, if you create one line, the second line will be denial. If you create 10 lines, right? If your list has got 10 lines, the denial will be the 11th line, which means this is going to be always the last line. Okay. So in that case, what I'm going to do is I'm just going to create one more entry here. I'm going to add one more. This is one, right? And I'm just going to create second line, and this line will become third. That will become the last line. Now, what I can allow here? Now I can go and say, I want to permit whom? I wanted to permit, right? I should not permit 1.3 alone. If I permit 1.3, then how will 4.2 other pieces they can talk to 2.2? Now, whom I should permit? I should permit any. So which means I need to permit everyone, right? So permit any. So now my first line is going to have deny host 1.2. My second line is going to have deny host. Sorry, permit host 1.2. The second line is going to have permit any. Okay, let's go and add that. Yes, assist one permit any. Okay, so now we just go and check the list. Do show access list. Now I can see there is a first line which is denying 1.2, and I can see there is a next line which is permitting everyone, right? Permitting everyone. Okay, now we just go and now this now we have three lines in the list. Okay, so now if I ping from 1.2, right? If I ping from 1.2, it's gonna match. It's gonna match on which line? It's gonna match on the first line, and it will get denied. If I ping not from 1 point, if I ping from 1.3, then what's gonna happen? Right? If I ping from 1.3, it's not gonna match on the first line. Now router will check which line? Router will check the second line. And what did I say? And everyone will match in the second line. And what is the action for that? The action is permit any. Right? See, if you guys are not getting it clearly, please watch the recording page one more time so that you will have an understanding better. Okay? Because I know, I'm kind of rushing up these topics now. Usually, I go in a very slow pace for these topics now. But the time constraint is something that I have to consider because we are starting upcoming batch on Monday. So only one day left for us. That is tomorrow. So tomorrow I have many topics to complete. That is right. Yeah. So let me just go and try to ping and check right now. Right. So now when I try to ping from 1 point, again I'm pinging from 1 point only. See, sorry. Again, I'm pinging from 1 point to which destination? To 2 point I'm trying to ping. That is getting denied because why? Now the ACL is matching on which line? The packet is matching on which line? The packet that is coming from 1.2 is matching on the first line. So getting denied. Now when I take 1.3, now when I ping from 1.3, earlier it was not working, no? Earlier it was not working. Now let me try to ping again. Now it works. Because why? Send a packet from 1.3. You send a packet from 1.3. Now that packet goes to the router interface. Router sees the first line, no match. So it's not gonna execute any action. Now it checks the second line. In second line, we told everyone can be permitted. So 1.3 is working. Now I can even take 4.3, which was not working first. I can take this guy, I can take 2.2. Can you see? He is also able to read. Okay. So this is the beauty of ACL. Okay, and I just wanted to ask you one question. The question is, right, assume that I have, let me just undo all these things. Okay, now I have these three lines. This denial is implicit, we cannot remove, that's going to be always last. Right? But can I have the ACL, right, in a different order? Can I create an ACL like this case? Can I create an ACL? The first line of my ACL is going to be permit any. Okay, which means I'm just going to swap the first and two lines, right? Here 1 and 2, here just going to be swapped, right? They're going to be 200. So permit any. And next line, I'm going to have deny. So after giving permit any, I'm going to say deny host 1.2. Okay. And next is deny all. Okay. So deny all, of course, the last line that's going to be always there. Now, do you think they have the same meaning, guys? Is this order and is this order are they same? Right? What will this now? If you take the second example, what exactly they mean? Right? Do you think 1 point will get denied with the second example? No, because why? Because now when you say permit any, everyone will match on the first line itself, right? If you say any, everyone is going to match on the first line and everyone will get permitted. So now the router, when you have a line like this, the router will never see the second line because why? Because only when the first line is not matching, it will check the second line. Now, according to your ACL, you say any, no, any means everyone will match on the first line and everyone will get permitted. Right? The router has got no chance to look into the second line. So it's the same ACL, guys, same three lines, but in a different order. So if you make things in a different order, you gonna be the meaning of the ACL is completely different, right? So in ACL, which is very important, means order, right? Order is very important. So in which order you write the ACL, that order only it works. Okay. Yeah. So when you configure ACL, what and all you have to take care of. Right? So first point is you have to choose the router. Choose the router correctly. Okay. For this one, can I go and apply the ACL on the second router? Right. For this, now for this to block, can I go and choose a? Can I go and create the ACL on the second router? No, there is no meaning in it, right? So because the router is very important, like correct router, right? Choose the router. Next is next is after choosing the router, you have to have the ACL in correct order. ACL in correct order. That is after choosing router, go and create ACL, but in a correct order. Okay. Next is you have to choose the right interface. Right? Choose the correct interface, because if you choose the wrong interface, it doesn't work. Right? Choose the correct interface. Correct interface in that router. Okay. Last one is you have to choose the correct direction. Choose the direction. Right? Correct direction. If you make mistake in any one of these 4 points, guys, your ACL is not going to work. Okay, choose the correct direction. Right? So what I mean by direction, that inbound, outbound, we are checking, right? So these are 3 points. If you choose the wrong router, completely wrong. If you choose the right router, but if the ACL is in wrong order, then it not work. After choosing the ACL right order, but if you apply it on the wrong interface, it's not gonna work, right? But even in the right interface, if you apply it on the wrong direction, that is also not going to work. Right? So these are the important points that you guys have to understand before you deal with ACL. Okay. Yes. So now here now we'll just go and start the external ACL. See, I'll finish external ACL maximum in 15 minutes, please, because we don't have time. I'll finish external ACL in 15 minutes. Just gonna give you a very brief idea about what is what. Okay. See, the basic difference in standard ACL and external ACL is standard. You block the IP address based on source IP only. Okay, standard ACL, you block the packets based on the source IP. In extended ACL, right? If you have an extended ACL, right, you can block the packets on these parameters. You can have source IP, you can block packets on source IP, you can block packets on destination IP. You can say if this is the destination IP, block it. You have more flexibility, right? And then maybe if you want, you can also block based on the protocol, right? You can block TCP protocol, you can block UDP protocol, right? You can block based on protocols, right? You can also block based on the services. Okay. So what I mean by services, for example, I know if you wanted to block WhatsApp alone, how will you do it? So if you want to block WhatsApp, WhatsApp is a service, correct? WhatsApp is a service, right? If you wanted to block maybe Zoom meeting, that's a service, right? So you can block based on the application also, right? So I can say instead of saying it as a service, maybe you can block based on application. Okay, so you can block based on application. So you don't want WhatsApp to work. That's possible in external ACL. You don't want Zoom to work. That's possible, right? You don't want websites to work. You don't want web protocol to work. Okay, or if you don't want ping to work, right? If you don't want ping to work, that's possible. We discussed, right? We telnet. If you don't want telnet to work, that is possible. If you don't want SSH to work, everything is possible, right? With external ACL, you don't have limit at all. External ACL is so great that you can block packets based on source IP, destination IP, protocols, applications. Okay. Yes. Now I'll just take a simple ACL here. Just gonna spend a couple of minutes with the first ACL example. Okay. Yes. So here in this one, right? Can you see 9-2? That is the ACL extended ACL. Here I see this. Okay. Now what I'm gonna do is I'm gonna go and it's the same thing, but we're gonna do it with extended ACL. The same task, right? The same task one, right? Here task one we did with standard, correct? The same example only, but here just it is gonna work with extended. Okay. Yes, let me start all the devices and make this work with extended. So task the same from 1.2, block 2.2 and 2.2. So yes. Now what I'll do is I'll just log into the first router and do it with extended ACL. Just give me a couple of minutes, guys. I'll finish this. Okay, so meanwhile, let it boot, but I just want to say one small thing. If you want to block based on the application, right? If you want to block based on the application, for example, if you don't want Telnet to work, or if you don't want SSH to work, or if you don't want the web to work, or if you don't want WhatsApp to work, right? So all these are applications there. If you don't want them to work, then there is a concept called port numbers. Okay, I'm not going to discuss about port numbers deeply here, but I tell you, right? Every service or every application has got a port number. For example, if you take HTTP application, okay, they have got a port number called 80. So which means HTTP means 80. So if you block 80, then you are indirectly blocking HTTP. And you know HTTPS, right? HTTPS is another web service. It's another application, HTTPS. That is with the number 443. And if you take SSH, the port number is nothing but a number, right? Uh, every service has got their own number. So SSH has got 22, and then Telnet has got 23. Likewise, I can say what else I can say? DNS, right? So DNS has got 53, right? And these guys are TCP. All these guys are TCP. This is TCP. This is TCP. This is TCP. But this is UDP. Okay, DNS is a UDP service, and you know, if you give me a few more minutes, I can think and I can say so many protocols also. FTP is there. FTP is there. DHCP is there, right? FTP uses 20 and 21, and DHCP uses 60 and 67, 67 and 68, 67 and 68. And there is something called email, right? We call it the SMTP protocol, email protocol that works on port number 25. There are so many things that we have. Okay, so these are the numbers. So which what I'm trying to say is, if you wanted to block web service, okay, then you can block 80. If you block port 80, then it's going to block web service. If you block port number 443, then it's going to block HTTPS service, right? I'll just show you this example alone. I cannot explain everything here, but I'll just show you a couple of examples with these two port numbers, and I'll show you whether it's working or not. Okay, so now I'm into the router right now. So EN config. Here I'm just gonna go and block. I'm just gonna use external ACL here, but this time we're gonna use in this first task we're gonna use source and destination IP. Right? I'll just finish this in a couple of minutes, and then next we'll take the next task and we're gonna block based on the application. Okay, yes. So source IP destination. Here access shall give, and when I give question mark, you can see for external ACL we can choose any number between 100 and 199. I'm just gonna use 100, and now question mark it is asking what do you want to do? I say deny. Okay. After I give deny, now can you see, guys? I told you in external ACL what and all you can use. You can use protocol also, which means you can use protocols like TCP to block, or UDP to block, or ICMP to block. So these are the protocols which you can block. I'm gonna go and choose IP protocol, right, which means any inter protocol. I want everything, any protocol should be blocked. I don't want TCP specifically. I don't want UDP specifically. I don't want ICMP specifically. I'm just gonna use IP, which means any inter protocol should be blocked. Right, I'm just using IP, deny IP, and now what it's asking for? It's asking for the source address, right? Now, what is the source? In this example, point is the source, right? So now he has got host 192.168.1.2. Okay, and then next is what is the trying to ping block from gateway 1.2, right? So I'll again give one more host 0.168.2.2. So what I'm saying is, from this source IP to this destination IP, I want it to get blocked. Right? See, this is only possible only in the external ACL, right? In standard ACL, you can just give only the source IP. You know, if you see the commands here in the standard ACL, like here, where is it? Yeah, here, there's an only one option which is you can just go and give only the source IP. Okay, where is it? Okay, so I'm just calling and showing you the standard ACL here. Yeah, it was asking only the source IP, right? This is the standard ACL thing. Now I'm showing you the external ACL. In the external ACL, you can see source IP 1.2 to the destination IP of 2.2. This is possible only in external ACL. Okay, again, I'm going to give one more command in which I'm just going to go and block 1.2 to 2.3. Okay, yes. So now let's go and see do show access list. Okay, so here I'm denying 1.2 to the destination of 2.2. I'm denying 1.2 to the destination of 2.3. Okay, and finally, of course, here also we have what happened is I'm creating an ACL and the ACL number is 100. We have denying 1.2 to 2.2, and also we have one more line called deny 1.2 to 2.3, and also we have something called permit, right? We need to add it, right? Because of course there is always what? There is always a denial line. So that is going to deny everything. So what we're gonna do is these two lines are not sufficient. We have to add one more line saying that what we have to say that permit. Okay. So permit what? We're gonna permit everyone else, right? So permit any to any, which means two any's, any source, any destination. Any source, any destination. So access 100 IP protocol, right? Any to any source, any destination. Okay, I think there is one mistake in it. Access 100. Okay, I need to say permit. Right? I need to say permit. IP any age. Okay, so hope you guys understand. Those who access list here. Now, when I give 100, when I check the list, it's list number 100, and it's denying 1.2 to 2.2, and it's denying 1.2 to 2.3, and everything else is permitted, right? We have two any's, any source, any destination can be applied. Now I can go and apply this ACL on this interface itself. Because why? Because now we also give the destination IP, right? Now source and destination IP both are given. So you don't have to go and apply on this interface. I can apply on this interface itself, right? So I can apply on this interface. If I apply on this interface, what is going to be the direction, right? The direction is going to be inbound. Okay. See, you can apply on this interface also, right? If you apply it on this interface, you have to give outbound, but no need to go there. We can apply it on our gateway itself. If the packet is coming from 1.2 going to 2.2, it's going to block. So here the direction is inbound, right? Because once the packet hits the interface, it have to check the source and destination IP. If it is 1.2.2, then block it. If it is 1.2.3, then block it. If not, then match the third line and then allow the packet. Okay. Yes. So now we'll try to apply this. So interface G0/0 applying on the gateway itself, IP access group 100 inbound. Okay. Exit. Yes. So now we can check. And just go and kind of ping request. 1.2 ping 192.168.2.2. It's not working. Okay. Let's check the do show access. Do show accesses. And can you see the matches are increasing here? 6 matches because we are pinging from 1.1. You know, we are sending packets from 1.2. To which destination? To 2.0 destination. So the matches are, can you see now if I again refresh it, can you see the matches are keep increasing? Okay, because it is coming from 1.2 to 2.0. Okay, when I try to ping 2.3, now you can see the packet increases on second line, right? The number of matches increase on the second line. Okay, and you can see here it increases on the second line. Okay, cool. So now let me cancel this. Now, if I try to ping 192.168, 4.2, let me ping 4.2. Okay, now it's working because matching on the because matching on. Can we confirm? Yes. Can you see packet matches on line number 7? Sorry, packet matches on line number 3, 7 matches. Okay, now it's gonna keep increasing because the ping is still going on. Hope you guys clearly understood. I might be a little faster. Usually how the ACL class goes is I do one task and I ask students to solve all the 6 tasks that we have in standard ACL, and then only we go for extended. I do extended and again I give the time for them to practice it. I know we are completing the concepts. The recordings are there definitely, of course. But in the live sessions, you are not doing it immediately, right? That is a drawback, of course, we have over here. Yes, we'll get into what we'll get into. Yeah, we can take 1.3 and we can ping from him, right? We'll take 1.3 ping 192.168, 2.2, right? This should work. Okay, that is also working. Perfect. Okay, yes. So this is the task I want to do in external ACL, right? Let me wipe this lab and take it to the next one. Okay, so now let's close this and then take it to the last lab named ACL, right? See, it's not that different. So only difference is so far we are using one now for number, I mean 1 for standard and 100 for extended. This is for standard and this is for extended. Now what we can do is instead of using the numbers, you can also use names. You can use a name and you can say whether this name is a standard ACL or this name is an extended ACL. That's possible. Okay, so this task, okay, where is it? Yes. Oh, maybe I think I took the wrong task. Okay, not this time. This is not the lab that I wanted to show you. I will delete this and I'm gonna go back to the CCNA folder. Please wait, please. I wanted to show you a different lab. Please. I copied the wrong one. It's here, extended, in which I'm just gonna clone this guy, move this guy, 3 labs. Okay, going back to our labs, bootcamp lab. Here, I just go and rename it. Yes. Yeah, so this is the lab I was talking about. Let me just go and start all the devices. Okay, here you have the port numbers. I told you, port number HTTP 80. So I'm not going to take all the PCs here. I'm just going to take this PC Windows machine alone. I'll just do a couple of tasks over here. Okay. So now what we'll do is, let me take a screenshot of this. Okay. So okay, now what we'll do is we'll take this router and we're gonna do ACL only. But first, what we'll do is first we'll check whether this guy can access the internet sites or not. He should be able to access the internet sites. And later, what I'll do is I'll go and block protocols like I'm gonna block HTTP, which is all the HTTP sites will be blocked, and all HTTPS sites will be blocked. So I'll demonstrate that way. But actual task is different. Here you can see the real task that I give in my classes. They are different due to time constraint. And if I start explaining this, it will take at least 2 hours to explain everything about external ACL. So just for the time, just because of the time constraint, I'm just gonna open this PC, show you first these sites are working, and go to the router and block them and show you. Just I want you guys to understand there is something called port numbers. Okay. Yes. Okay. So we'll go to the router, or maybe we'll go to the PC, log in into that device, check whether the sites are working. Okay, so let's go and make a ping to 8888. Of course, internet is working, ping is working good. Let me just go to the Chrome browser. I am just going to use test.networking.in. I'll have this guy in HTTP protocol. It's HTTP. Can you see HTTP? Okay, the site is working right now. And for HTTPS, I'll just go to google.com itself. Google.com. Okay, maybe I can add HTTPS and google.com. Okay, we're gonna get the Google site also working now. Okay, there you go. Both, everything is working right now. Okay, now I'll go to the router and create a couple of lines, right? Not just 3 lines. So en config access list, or maybe I can use a name, right? If you want to use the name, what you can do is you can just go in. There's a different command for this. I'll just give you IP accesses, and you can choose a name, right? You have to say whether it's standard or extended. I'm going to choose extended, and I'm going to give a name. Right? The name is going to be, I'm going to say NGACL, and I'm into the ACL mode right now. This is the named access control list. Okay, I'm going to say deny, deny. And what protocol we're going to deny is, I told this HTTP, protocol, they belong to TCP, right? I'm going to go and deny TCP here. So I'm just going to say deny, and in the protocol, I'm just going to choose TCP. Okay, in TCP, what is the source address? Host 192.168.1, because 1 point is the Windows machine. This guy, he is 1 point, right? And then question mark here, we're going to have the destination address. The destination is, okay, what is going to be the destination, right? Are we going to really call the destination here? No, the destination is going to be any. The source IP is 1.2, the destination is any, right? The protocol is TCP, right? And if the application is 80, then deny it, right? The destination IP is any, guys. We're not going to go with any specific destination. If the destination is any, what is the meaning of it? Internet. Any destination in the internet, website should not work. HTTP protocol should not work. That is what I'm saying. Okay, I'm going to say any destination. So if the source is 1.2 and if the destination is any destination in the world, I want the EQ, right? This is where the port number starts, EQ, and I would say 80. So this 80 means what? HTTP protocol, right? Which means it's going to block right now all the website HTTP traffic. Now I'll just go and give 443. What HTTPS port number is? I don't know. HTTPS, it has got a reserved number for itself, which is 443 equal to 443. Good. Now, next thing is, of course, the denial statement. We have to clear that. So for that, I'm going to say permit IP any. Okay. So now let's go and check the line, check the ACL, do show accesses. Okay. So we have a deny line for 1.2 going to going to any internet destination. If the service is 80, then deny it. If the service is 80 means www, that is the HTTP protocol. And if it is 443, also deny. Okay, and then that means HTTPS. If not, then allow anything, right? So we created an ACL only for 1 point. Okay, so now I'm going to apply this. So we'll go to the interface and apply this. So I'm just going to give exit from the ACL, go to the interface, G0/0, IP access group. Okay, and here the name of the ACL is NGACL inbound. Okay, so I'll give the commands definitely, guys. I know I'm just fast forwarding very fast. I know. Let's go and click on this guy. earlier it was working, earlier it was working, right? Now let's go and see whether it's working or not. I'm just gonna take a private browsing so that I don't mess with the caching here. So when I try to give test.network, it is not working right now. Why? And you can see, if I just give up arrow here and give the ACL, can you see the lines are getting matched, right? The lines are getting matched. And also, you can see it is not working right now. It is not getting connected, right? Can you see it's connecting? Earlier it was there. Now see, it took long to respond. It's not working. Now when I try google.com or maybe HTTPS or google.com, even that's not going to work. Okay? That's not going to work because why? Because google.com, now the protocol I've given is HTTPS, right? But what about ping? Do you think ping will work? Ping 8888. Do you think ping will work? Ping will work because why? Because we blocked only port 80 and port 443, right? So ping is basically working. Okay. Yeah. So with this, I'll finish a case. I know this session was so short, and explaining ACL will take at least 2-3 hours of time, but we just try to understand in 45 minutes. Yeah. So I'll finish it here. So tomorrow we'll meet with next topics, new topics like NAT, VPN, and firewall. Tomorrow is going to be the last session. So please do join everyone. Okay. So we'll meet tomorrow. Okay. Thank you. Bye.